in this last graph, we're going to talk about time series graphs. The name implies a little bit about what they have to do with, which is time. I don't know why that came out so awkward. Please don't judge me. And we know time is a measured quantity, so we know we are solidly in quantitative territory. So we use this for quantitative data. And we always plot time on the x-axis versus something else on the y. And that could be anything else. We're looking at, in time series graphs, something changing over time. And so time is our independent variable, goes on the x, and then something else is the dependent variable that goes on the y. We're going to go ahead and do an example so you can see what these look like. So we have a table that is a portion of a data set from worldbank.org. Use the table to construct a time series graph for carbon dioxide emissions for the United States. And I can see that this chunk of the table has data for years 2003 to 2009, and then carbon dioxide emissions for Ukraine, the United Kingdom, and the United States. So I need to plot this on a time series graph. I know that this is my time, so that's going to be my x-axis. If I could get my pen to work. Why did we stop working? Uh-oh. Did I kill it? Oh, I didn't kill it. I just pressed it. Sorry. And then United States is going to be my y. My instinct says, because I don't want to have to plot all the way out to the tiny decimal, that we do 5.68 million, and we scale our axis in millions. So this would be 5.79. This would be 5.83, 5.74, 5.83, 5.66, and 5.30 if I round to 2 decimal places. I think that'll be a little bit easier to graph. I can see that my smallest is going to be 5.3. My biggest is 5.83. That's a lot easier to count by. So that's the plan. I know that when I draw this graph, I'm going to do time on the x and my other variable on the y. So let's go ahead and do that. So I have 1, 2, 3, 4, 5, 6, 7 data points. So we'll start here. I need to go out 7. And this is plotting time in years. And we started with 2003. So 203, 04, all the way up to 2009. For the vertical axis, the smallest is 5.3. My biggest is 5.83, which would be 5.85, I think, if I count by 0.05s. So let's do that. So 0.3, 0.35, 0.4, 455, 556, 657, 758, 85. So I think we just fit if I go all the way up here. to label this axis, and this axis is CO2 emissions for the US. And please don't judge me, I cannot spell one M, two S's. And then I need to put units. And they didn't tell me what they measured it in, but I know that it's in millions because I changed my data. From here, I'm now just plotting my ordered pairs. So 2003 should be at 5.68. So just a little bit below 5.7. My next one, 2004, is 5.79, so just under 5.8. And then we've got a 5.83, and then a 5.74, and then another 5.83. And then 2008 is 6.6. And then 2009 is the 5.3. The very last thing we're going to do is play connect the dots, just like we did with frequency polygons and ogives. So I'm going to go ahead and connect from that first point to the second, and then I'm going to work my way across the graph that way. All right, if you have any questions on time series graphs, feel free to send me an email. Otherwise, I will see you in our next video.